Today we talked about prime numbers and composite numbers. And a prime number, the difference between a prime number and a composite number is that a prime number could only be divided by itself and 1 and nothing else. Where a composite number can also be divided by other numbers, at least one other number. So we have this list of 4 numbers and we need to determine whether they're prime or composite. So here's a way you can do that. If the numbers are less than 100, which all the numbers that we're going to deal with on this topic are, all you have to do is go through these divisibility rules plus my numbers that are not on that list, 4, 7, and 8. And if a number is divisible by any of these numbers, then it's composite. If it's not, it's prime. So I'm going to go through each of these step by step. We're going to start with 11. We're going to determine if 11 is prime or composite. Now, is 11 divisible by 2? Well, it's an odd number, so it is not divisible by 2. Is it divisible by 3? Well, our 3's rule is to just add up the digits and see if it's the whole thing's divisible by 3. So 1 plus 1 is 2, and 2 is not divisible by 3, so 11 is not divisible by 3. Let's see if it's divisible by 5. Is the last digit a 0 or 5? No, it's a 1, so it's not divisible by 5. Is it divisible by 6? Well, if it's divisible by 2 or 3, it's divisible by 2 and 3, it's divisible by 6. Well, it's not divisible by either one of these, so it's definitely not divisible by 6. Now, my 9's rule is you add up the digits, and if the sum is divisible by 9, then the whole thing's divisible, then my original number is divisible by 9. If I add 1 plus 1, I get 2. That is not divisible by 9, so 11 is not divisible by 9. So let's divide it by 4. 4 goes into 11 2 times, and I get a remainder of 3, so it's not divisible by 4. Let me try dividing it by 7. 7 goes into 11 1 time, and I got a remainder of 4. That's not divisible by 7. And I will try to divide it by 8. 8 goes in 1 time, and I get a remainder of 3. So this is not divisible. 11 is not divisible by any of these numbers, so it is prime. I'm just going to put P for prime. Now let's try 73. Is 73 divisible by 2? Well, it's not even, so it's not divisible by 2. Is it divisible by 3? Well, let's add up the digits. 7 plus 3 is 10, and 10 is not divisible by 3, so 73 is not divisible by 3. It does not end in a 0 or 5, so it is not divisible by 5. It's not divisible by 6 because it is not divisible by 2 and 3. And if I add up the digits, that equals 10. 10 is not divisible by 9, so 73 is not divisible by 9. So let me try to divide it by these 3 extra numbers that I don't have rules for. 73 divided by 4. 4 goes into 7 1 time. And 4 goes into 33 8 times. And I get a remainder of 1. Not quite divisible by 4. Now let's try 7. 7 goes into 7 1 time. And 7 goes into 3 0 times. I get 10, remainder 3. Not divisible by 7. So let's try 8. 73 divided by 8. 8 goes into 73 9 times. And I get a remainder of 1. So it is not divisible by any of these numbers. 73 is a prime number. Now 69. Let's go to the list for this number. 69 is not divisible by 2 because it's odd. Now let's see if it's divisible by 3. 9 plus 6 is 15. 15 is divisible by 3, so 69 is divisible by 3. So this is composite. As soon as you find something this is divisible by, you can stop. It's composite. 42. 42 is divisible by 2 because it's even, so that's composite. That one's very easy. We can tell right away. So here are some questions or some statements, and we have to determine if they are true or false. Okay? The first one states the number 1 is not prime. Is that true or false? Well, a prime number has 2 factors, 1 and itself. Well, 1, it turns out, only has 1 factor, which is 1. 1 and itself are the same thing in this case. So because it does not have two factors, it only has one factor, it is not a prime number, so this is true. Okay, now let's take a look at this one. A composite number cannot have three factors. Is that true or false? Well, it turns out this is false, and I'll show you why. I'm going to take a composite number, 12. 2 times 2 times 3 equals 12. Three factors make up 12. So I just demonstrated that that is not true. A composite number can have three factors. A prime number can't have three factors, but a composite number can. Okay, now this one says only odd numbers are prime numbers. Now it's true that most prime numbers are odd. In fact, almost all of them are odd. But there's one that is even, so this is false. And there's only one single prime number that is even. That's 2. Everything else that's even is composite because it can be divided by 2. But 2 is a prime number because it only has two factors, 1 and 2, and that's it. So it is a prime number, the only even one. The last one, it says every multiple of 7 is a composite number. So is that true or false? Well, let's write down our 7s. 7, 14, 21, 28, 35, 42, 49. Well, I can tell you that everything from here on out is composite because they're divisible by 7 and itself and 1, and then another number. But this one is actually a prime number because it's only divisible by itself and 1, and that is it. So this is false. This is false. There is one multiple of 7 that is a prime number, and that is 7 times 1, which is 7.